Okay, so in this presentation I start here with these slides about the natural gas. Namely, what is a natural gas? Basically, the natural gas is a mixture of hydrocarbons, where the methane represents about 90% of this total mass of this mixture. Then we have the ethane, about 5%, and then all the others are around 1%. The LNG is the natural gas that, by the effect of the temperature reduction, becomes a liquid, so it's in the liquid state. The methane at the ambient temperature it's very difficult. It's almost impossible to condensate. We need to get a very high pressure, above 300 bar. So the way that we have to put this mixture, the natural gas, in the liquid state is by the reduction of temperature. We do this to have effective way to transport and to storage. Because when we put the gas in the liquid state, the volume reduces about 600 times, which is much more effective for the storage and the transport. Other temperatures, other properties, is the cleanest fossil fuel. Is the one that, in terms of emissions in CO2, particles, and NOx is the one that have the less emissions. And in particular, when the natural gas is obtained from LNG. This is when we have the liquefaction of the LNG, this process removes some of the contaminants, some of the contaminants that we have in the natural gas that came by the pipeline. Is colorless, is odorless. It's not toxic, but is asphyxiant. That is, if we have our air, if we have this gas in such a concentration that removes the air that we have to breathe, then we can asphyxiate with this gas. When mixed with the air, becomes inflammable. The ratio is about 5 to 15% by volume. At ambient temperature is lighter than the air. So this in terms of safety is very good, because if I have a leak of natural gas, that leak will not travel on the ground level. That is, if I have a leak, the leak immediately raises in the atmosphere, and by doing that, it will be apart from the places where we should have the ignition sources. It's not corrosive and is a good lubricant for us here in the installation. This is very important, because keep our equipment in a good shape for the operations. We don't have the type of problems that certain chemical and petrochemical plants have, that's due to the corrosion. They never know what are the thickness of the piping, what are the thickness of the pressure vessels, because they built the pipes with a certain thickness, but after a while the thickness will be reduced. Here, that's not the case. Okay, this is just a brief introduction about what is the natural gas. Then let's talk a little bit about the terminal. The natural gas in Portugal, the project of the natural gas in Portugal starts with a big debate if we should start with an LNG terminal or with a pipeline. This was a discussion that was taken about the beginning of the 90s, and the decision was to build first the pipeline. So the first project to put the natural gas in Portugal is a pipeline that is coming from Algeria. It's crossing the north of Africa. It's crossing the Gibraltar Strait, and is arriving in Portugal in Campo Maior. And we consumed the first natural gas in Portugal in the year 97. But just after starting the operation of the pipeline, the Portuguese government take the decision to also build a plant like this. So in '98 we have the first decisions from the government to build a plant like this in Portugal. The construction, then we have a process of EPC tender, and the construction starts in the year 2000 and ends in the year 2003. Well, officially it was 2004, but we received the first cargo. We received the first cargo in 2003. As I mentioned before, this cargo was dedicated to the cool down of the plant. It's not yet the commercial activity, it's more for the cool down and for the commissioning of the plant. In the beginning of 2004, we have the startup of the commercial activity. We have the provisional acceptance. Provisional acceptance is the end of the construction, is the official end of the construction. We obtained the operating permit, and we have the opening ceremony, all these actions at the beginning of 2004. Then, in the beginning of 2006, we put in the Portuguese law a European directive related to the unbundling. And this European directive stipulates that the companies that have assets of natural gas, terminals, pipelines, underground storage, cannot have the commercial activity in the same company. So at that time, we were segregating from the company that had the commercial activity. The commercial activity stays in the Galp group, and we were bought by REN, and since then, that was in the end of 2006 in September, we moved to the REN group, and we are in the REN group since then. More recently, in 2009, we make an expansion of our facilities, so we have another construction project, an expansion. You can see here in this picture, the original project was these 2 tanks and this process area that we have near the 2 tanks. In the expansion project, we built another tank, the 3rd tank, and this process area that is also near the 3rd tank. Basically, it's like building a terminal in parallel to the existing one. It was also a project of 3 years, so we end this project, the provisional acceptance, it was in 2012. Okay, so this is a little bit about the milestones of this facility. Referring a little bit the value of the LNG and the value of this plant for the Portuguese natural gas system. Before the terminal, we have one producer that is connected to the Portuguese system. So we are connecting a producer to a consumer by a pipeline. So this system, it's very weak, because if we have some problem in this system, we compromise the supply of natural gas to Portugal. With the terminal, we create a new entrance of natural gas in the country, with the particularity that is, we are no longer linked to a certain producer. We can import natural gas in the liquid state from whatever source. We can go to all the sources of the world, because usually the composition of the natural gas is very similar around the world. And in Portugal, we have our spec, that is what limits the gas that we can put here in the Portugal, in the terminal. It's a little bit wide, so we can receive a natural gas, I would say, from any source of the world. And by doing that, we are diversifying the sources of supply, and we are increasing the safety of supply. This is also very important for our shippers. The shippers is the people that have the gas. We are not the owners of the gas in this plant. The shippers are the ones, like Galp and Desa, that bought gas in the market and put the gas here in the terminal. This is also very good for them, because in the past, they are limited to one source. We only have one source. So you can imagine that in commercial terms, this is not very good, because if I need to buy something but I only have one supplier, this is not good for me. With the terminal, my shippers can go all around the world to make the business of, they can buy gas in what source. So they have this, the power to negotiate the prices of the gas. They also have the possibility to go to the spot market to buy gas in this spot market. And usually the prices of the spot market are lower than the prices of the long-term contracts. And by doing that, we create a way to have gas at a cheaper price here in Portugal. Other advantages of the plants, we have a very high capacity, a very high send-out capacity that we can supply the whole country by this plant. Maybe the interconnections to the plant are the weakest point of this situation, because the pipeline that is connecting the terminal to the grids does not have the same capacity of the terminal. But we have a very high capacity, so we can supply the complete country by this plant. This also allows the implementation of this philosophy. The N-1, sometimes it's N-1, and other times it's N+1 philosophy in Portugal. This is also a requirement of a European directive. We also have the possibility to supply LNG by truck to all the areas of Portugal that are not connected to the pipeline. I can show you one picture a little bit ahead. Yes, like this. You can see that our pipeline is installed mainly starting in Sines along the coast, to the north along the coast. Okay, we have some pipelines in the countryside to Guarda, but mainly the Portuguese grid is on the coast side, starting in Sines to the north of the country. If we go to Trás-os-Montes, or if we go to Alentejo or to Algarve, we don't have grid, we don't have pipeline grid. So the only way that these areas have to have natural gas is by truck. We load the trucks here in the liquid state, they deliver in a satellite units, and then they can consume natural gas in these areas. This possibility also prepares the country for these new markets that is the small scale. So these are new ways to consume natural gas, namely the one possibility can be the transports, the roads, heavy trucks by roads, or the maritime transport that can consume the natural gas in the liquid state. But this is also applicable to any other possible solutions that are related with this new market of the small scale. Another important feature is that in the near future, this is for 2025, we will enable Portugal to fulfill this directive, the 2014-94, that stipulates this deployment of alternative fuels infrastructure. Namely, what it states is that in Portugal we should have capacity to supply LNG to power the ships and to power the heavy trucks on the road. On the roads we should have these filling stations no more than 400 kilometers. In the ports we should have the main ports with the capacity to supply the LNG as bunker fuel for the ships. This is the geographic surrounding of this plant. In Portugal, we are the only plant like this. But Spain have a lot of tradition in terms of LNG. Spain, because it's quite far away from the eastern pipelines, they decide to have this solution of the LNG terminals. A long time ago, they have the first LNG terminal starts in '69, so they have more than 40 years of knowledge in this technology of the LNG, and they have at this time seven LNG terminals. I think only 6 are in operation, but they have a good installed capacity in terms of LNG. in terms of the functions of the terminal, what are we doing here? Well, this is a regulated company, so we operate under the terms of a concession, and that concession stipulates the function, what I call the concession functions. Okay, so it's the reception and unloading of ships, the storage, and the regasification to the grid. Okay, I had in the regasification the loads of trucks. This is also related with the concession. Let me tell you that the storage here is not a strategic storage. This is only an operational storage. It's just to allow the continuous emission to the grid, because here we operate 24 hours per day, 7 days per week. So we need to have the capacity to put the gas in the grid continuously, but we are only receiving ships every 2 weeks or something. So we need to have a storage to enable this operation. More recently, we also implement other activities that we call the complementary activities, like the gas in, cool down, and ship loading. Ship loading is the opposite of ship unloading. So basically, it's put LNG in a ship that was in our tanks. We also perform some maintenance and operations training to other LNG terminal operators, and we also give some technical assistance for the commissioning and startup of those terminals. This is something that after 2008, the first natural gas crisis of Ukraine, that Ukraine shut down the valves, Europe decides, most of the European countries decide to create a backup solution for their countries. And the solution that they had is to install LNG terminals. And we see LNG terminals being erected in Netherlands. The European countries that have LNG terminals decide to build more terminals, like in France, in Spain. A lot of projects after that year appeared in Europe, and we gave this assistance. This is the technical diagram. I believe this is a part that is very interesting for you. This is the technical diagram of the plant. It's basically, I can give you just an overview. This is the jetty where the ships berth to make the unloading operation, unloading or loading. So we have these unloading lines up to the storage tanks. These are the storage tanks. And this is the main process equipment. We have here the recondensers. Now we have two because we make this expansion project. So we have like two terminals in parallel. We have here the recondenser, the high pressure pumps, the vaporizers, and then here is the same. Here we have a seawater intake station, that provides the seawater to supply. It's from the seawater that we take the heat to make the regasification of the gas. And then we have the pipeline to interconnect to the pipeline. In terms of process, let me just give you here just a brief explanation what is the process. So the unloading is quite simple. So basically we connect these equipments to the ship, 4 unloading arms, 3 are dedicated to the liquid transfer, and 1 for the vapor return. So we put here the ship, we connect the equipments, and we make the unloading for the tanks. Well, this is not as simple as I'm telling here. The people of operation knows much more about this than me. But this is done with a lot of attention to the characteristics of the cargo, the characteristic of the LNG that we have in the tanks. We decide if we make the transfer by the top of the tank or by the bottom. Well, and all this process is much more controlled. This is not open the valve and go ahead. Okay, in terms of storage, we don't need to do much. It's just to monitor the condition of the product that we have there. We have ways to monitor the characteristics of the LNG that is stored, namely to check if we are near or if we can have certain characteristics that indicated that we are having stratification in the tanks. Usually in our case, we never face this problem because the rotation of the LNG in the tanks is very, very fast, and we don't create the conditions to have this stratification. But anyhow, the operations, they monitor the conditions of the LNG to check if that is occurring or not. And then the send out, the emission to the grid. Basically what we do here is the following. We pressurize, just a reference, the product in the tank is very near the equilibrium, okay? Especially the top of the tank, this layer that is here on the top, I would say this is really near, or at a certain point it is in equilibrium, like we saw before in this small vessel. But at the bottom, because we have here some hydrostatic column, okay, we have already some pressure. So at the bottom, we should have already the liquid a little bit subcooled. What we do is we put here some pumps. These are submerged pumps. We pressurize the liquid a little bit, up to I would say 10 bar. It's a little bit more, at 10 bar. And we do the same to the vapors that we are taking from the top of the tanks. As I mentioned before, the product is in equilibrium, so it's always generating some vapors. And we don't want to put these vapors away to the atmosphere. So what we do is we take the vapors here, we pressurize in compressors the vapors at about the same pressures that we pressurize the liquids in the low pressure pumps, and we mix here in the recondenser. And basically what we are doing here is we mix the subcooled liquid with the superheated vapors, with the parameter properly controlled in such a way that at the end of the vessel, at the end of this recondenser, we get a liquid a little bit subcooled. Basically, this recondenser, I would say, is like having an open rack heat exchanger. You see, all the fluids, liquid and vapor, are going to join at the top of the vessel. They are going to pass across a mesh of metal that is there. The liquid cool downs the metal, the vapor condensates in the same metal that is cooled. And at the end, we should have these two fluids getting only liquid. Okay. At the bottom, okay, we have here liquid. We pressurize it again a little bit more with these pumps. At this time, we are going to put the product at about 90-95 bar. But okay, at the end of the pumps, we have already the right pressure to put in or we have already enough pressure to put in the pipeline. But we are still, the product is still a liquid. What we do at this stage is to put the product in a heat exchanger, and the product is going to receive the heat from the seawater. Basically, we are pumping seawater from the sea. We are putting the seawater in this heat exchanger, and the seawater will transfer the heat required to make the regasification and the warming of this gas, in such a way that at the end of the heat exchanger, we have the product at enough pressure and with the right state, it's vapor, it's gaseous, and with the right temperature to put in the pipeline. So I would say that the pipeline starts here at the end of the vaporizer, at the outlet of the vaporizer. So this is, here we have a gas line that is going to interconnect to the Portuguese natural gas grid. The only thing that we are still missing is to make the accounting in terms of volumes and in terms of composition, what we are putting in the grid. So we measure volumes in the flow meters, turbine and ultrasonic, and then we measure the composition of the gas with a chromatograph, and we make the product of the volumes by the calorific value that we can calculate from the composition, and we get the amount of energy that we are transferring to the grid. The balance here in the plant is done by energy. Okay. So this is basically what we do here. I missed the loading of the trucks, but the loading of the truck is very simple. It's just from the low pressure circuit, we feed the truck loading station. So we load the trucks at a very, very reduced pressure. And again, we have the return vapor from the tanks to interconnect to our oil-off gas system. Okay. A diagram about the tanks. This is basically the tanks that we have in the plant is what we call the full containment tank. It's like having two tanks one inside the other. Okay, the product is contained in this metal. The product is contained in this metallic tank, what we call the inner tank. It's a metallic tank with 30 millimeters, 9% nickel steel. And then we have the insulation. We have here perlite, we have here foam glass, we have here at the top rock wool. All the system is insulated. And on the outside of this tank, on the outside of the insulation, we have another tank of concrete that is able to contain the liquids if we have a leak on the internal tank. But this one is concrete. Well, they have a layer here. They also have a layer of carbon steel. But okay, it's a concrete tank. It's a concrete tank, and this concept creates a tank that is very safe because it's like having two tanks. If we have a problem in one tank, the product can be contained by the outer tank. Then we have here some funny things. For instance, just for a question of safety, all the entrance or the exits from the tank must be done by the top. In these type of tanks, it's not allowed to have pipes or cables coming from the walls. All the entrance and all the exits must be done from the top of the tank. This avoids the creation of weak points below the liquid level. Okay, so in terms of leaks, this also is very, very, very safe. Another particularity, okay, this is an insulated system that we try to avoid as much as possible the ingress of heat in the tank. But it's funny because at the bottom we have here a heater. We have here a heater at the bottom of the tank. This is to avoid that the low temperature of the LNG reaches the bottom of the slab in such a way that the water can freeze at this level. I don't know if you have already saw, but sometimes when you have the water freezing, and this is sometimes this cycle. The water freezes in a certain conditions, but then at a certain conditions it melted, and these cycles makes like that. If we have the water can ingress in the cracks of the concrete. When the water freezes, expands and increases the crack. And then when it melted, it goes a little bit more and creates here a process that in a small period of time, a few years, can destroy the foundations of the tank. To avoid that, we have this bottom. Okay, then we have here a little bit about the statistics of our activity. This is the number of ships that we received so far. Do not forget that we start the commercial activity only in 2000 and only in 2004. The 2003, the 3 ships are only for ground and commissioning activities. Okay, so this is the evolution of our activity. I would say that until 2011 we have a more or less constant growth in terms of activity, but after 2011 we reduce a little bit our this is a little bit the same information, but looking for the total consumption of natural gas in Portugal and the ratio, the contribution of the terminal for that consumption. In blue, we have the contribution of the terminal. In green, we have the contribution of the pipeline. As I mentioned before, we have two ways to feed the Portuguese grid, is by the pipeline or by the terminal. And as you can see here, until 2011, we represent more than 50% of the total gas that was consumed in Portugal. But after 2011, this was generated by the Japanese crisis, the problem of the nuclear power plants in Japan. After 2011, we dropped a little bit the activity. 2014, it was the worst year of this terminal, and now in 2015, we are already recovered a little bit this activity. Then we have the truck loading activity, the number of trucks that we load here in the plant. And in this activity, I would say that we have a constant growth in terms of activity. So here we don't have much competition from the pipeline or from other sources of energy, and we are increasing in a constant growth. Okay, and then we have some pictures, just to finish, some pictures about the terminal, the process area. Before we have, we have here the jetty, where we port the ships and the ships and boats. The process area. It's jumping off. Sorry. This is not the sequence. Is not normal. Okay, but this is the process area. This is the jetty, and this is an overview of the terminal. Okay. Okay, do you have any question, any doubts? Not much.
We saw that you have loaded more or less 6 ships here, right?
Loading activity.
Yeah.
Yes, I don't mention too much. I would say the following. In the last years, yes, we have more or less 6. I believe that in the next year, we should lose this activity.
Do you know the destination of that ships? Or
yes, mainly we load these cargoes to Brazil and Argentina. Mainly Brazil, Porto Pecém, so I think so. But this is, I would say, this is not a normal activity. Because here we don't have any source of natural gas, so we should not export.
Yeah.
But this was a business opportunity that was created due to the high prices of the natural gas in the market, and due to the fact that some of the shippers that put gas here, they have first they have the option to feed our grid in 2 ways: the pipeline or the terminal. So what they see here, it was a business opportunity because the LNG in the international markets was at a very high price, and they can export the LNG. The gas that is coming from the pipeline, the price is fixed because it's a long-term contract, and they cannot export this gas. So they decide to feed the Portuguese system with the pipeline gas and to use the quantities that they are available in the long-term contracts, the long-term LNG contracts, to sell in the international market. But at the beginning they have a problem. I believe, I don't know the details of the contract, but I believe that at the beginning they have a problem. That was the contracts that they have a destination closure. So they cannot resell the gas directly with the same ship, that is telling the guy of the ship, hey, you are not going to discharge in Portugal, you go to Brazil. No, they cannot do that. Later, I think they negotiate this closure, and they did something different. But at the beginning, they put the gas here, with 1 ship, then they find another ship and they transport the gas to Brazil, and by doing that, they avoid this destination closure of the contract. This is something that now the prices of the LNG are dropping.
Mhm.
I believe that for the future we are going to lose